Grade 12 applied. Lesson 3, quadratic and cubic regression. So we're continuing along the patterns of regression, but now we're going to do quads and cubes. Okay, so what we got here is, let's look at the first part. Audrey knows there's a relationship between the speed of a vehicle and the distance needed to stop. So we have a bunch of data. And what we got to do is we got to put that data into the TI-83. So we're going to put speed as L1, distance as L2. So grab your TI-83. Remember, go to Stats, go to Edit, and then you can put in your lists under L1 and L2. You make sure they have the same number in each one. Now, I've already put these in, so you'll have to pause the video, put the numbers in. Okay, now once they are in, we need to create a stat plot. So if you remember how to do that, let's go down here again. What we're going to do is stat plots. And we go to second y equals, that's stat plot. There's our first one there, plot 1, hit enter. And we got to turn it on. So now it's on. Okay, so now we have stat plot on. Right? You can leave it on all the time. You don't have to turn it off all the time. And we want to graph this, so we're going to go to zoom, right? And remember, we can go to zoom stat right there, because it'll set up the window for us nicely. Instead of you having to set the X and Y values, hit enter. Let's see what we get. Oh, there's a bunch of data there, a lot of it. And what we want to do is we want to create the line of best fit for this one. So to do that, we have to do some quadratic regression. So this part here is our quadratic regression. So we go back to stat. We go over to calc. We go down on calc here to hit quadratic regression. Now hit enter. Again, you can put L1, L2 for the list. You can change the list if you have multiple information, but the default is L1, L2. Hit enter, and what it's going to do, it's going to calculate the equation, the quadratic equation that goes with all that data. So the standard form here is y equals ax squared plus bx plus c. And a, b, and c are just your coefficients and constants. So what that looks like in equation form, and I did this to 4 decimal places, your a is like 0.0101. So you got y equals 0.0101 x squared plus 0.3645 x minus 7.0916. So there's the equation. Now, we got to get that into the window so we can graph that. Now, again, you can write all these numbers down, but that's a waste of time. So go to y equals. And right here is that where y1 is. We want to put that equation. Now, if you remember, it's under vars. So we go to vars. We go down to statistics. We go across to EQ where that regression equation is set up there. And whenever you do a regression equation, it automatically throws it into that point. So we hit enter, and whoa, look at all the numbers it throws in. So if we graph this now, what it's going to do, it's going to fill in the line of best fit for that set of points. And it's a quadratic regression. You can see it's sloping up. It's basically part of a parabola there. So then we have it. Awesome. So then what we can do is we can use that now to answer a whole bunch of different questions. So estimate the stopping distance of a car traveling 50 kilometers per hour. So this is, again, that X value, right? We're going to go to second calc, and we want to put in the X value set to 50. So hit enter for X value, and type in 50. Hit enter, and it should return our Y value. And there it is right there. You can see at the bottom of the little screen here. So 36.3619. So there it is. There's our Y value that goes with that. Really easy to find those questions. The harder part is when it looks at the next part and it asks you to find stopping distance was 28 meters. What's the approximate speed? So we got to go backwards in this case. So what we got to do is this is the one where we draw the horizontal line and find the intersection point, just like we did with linear. So y equals 28. That's where we're going to draw our horizontal line. Now, if you remember, you go to y equals. There's our first equation there. So we go down to y2, and we're going to plug in 28. And it's going to draw a horizontal line on that graph at y equals 28. So we hit graph there. There it is. And we want to find the intersection point right there. You can't see it on the screen. There's too much data. So what we can do is we can actually get the calculator to do it for us. So we go second calc. Right? We go down to find intersect, because it's going to find the intersection between those two. First curve, second curve. Basically, it's the two lines. Remember, it always gives you that guess in there. Make sure you hit enter one more time past it. And it returns a value of, there it is there. So when y is 28, x is 43.6127, right, meters. Right? So it's really quite easy once you get the data in there. Okay, now, what we're going to do is we're going to go next page. And we're going to do the same thing again, but we're going to do this with cubic regression. Okay? So I just got to pause the video so I can load all the information in the calculator. Give me 1 second. Okay, so what we can do is we're going to take this data here, and this is gasoline per liter 30-year period beginning in 1979. So this is years after 1979. So you got to remember those because it's going to ask us a question later on. So again, L1 and L2. To do that, grab your TI-83, stat edit. So stat edit, right? And you're going to put them into L1 and L2. Now I've already put them in, save some time. So you'll have to pause the recording, put all that information in. Okay, so now once the information is all in there, we can create a scatter plot. So to do that, what we do, if you remember again, and I'll go through the steps again. Second, all right, let's quit. Second stat plot. We got to turn the first one on. It's probably on from the last time, but I always make sure it's on. Okay, so it's on there, right? And then put that one, and we got to set up our window to zoom and zoom stat, right? Because then it always picks the statistics one. Okay, we hit graph. Let's see what it looks like. There it is. There's a bunch of data. Okay. Well, we need to put the line in here because that's just the data. To do that, we need to do regression. We need to go backwards and figure out what the equation is to do that. Now, this is cubic, so we got slightly different, but the pattern is still the same. So we go to stat, we go to calc, we go to cubic regression, hit enter. Again, L1, L2, or the default is when you hit enter, it'll just do that for you. Take a couple seconds here, and it'll give us the cubic regression equation. Now you can see there's the pattern up the top, y equals ax cubed plus bx squared plus cx plus d. And there is all our values of a, b, c, and d. So what I've done is I've written them out here out of 4 decimal places. It's a big cubic equation. Now, we got to get all that information into y equals so we can actually graph the line. So we'll do that very carefully here. So we go to y equals. There's nothing there right now, but do you remember where it is? Yeah, it's under vars. So we go to vars. We go down to stats, statistics. We go to EQ, and there's the regression equation. Puts it in there every time. Hit enter. Wow, look at all those numbers. Can you imagine typing that in? That would be ridiculous. So hit graph, and now what it's going to do, it's going to do the line of best fit for that one. Oh, there it is. Perfect. So there it is right there. So we have our information. So now what we can do is we can use this graph to answer questions. So let's look at the first one here. Estimate the price of gas in the year 2001. Now, the problem is if you put in 2001 as your X value, it's going to be really, really weird. Remember, this is for after 1979. So 2001 subtract 1979 is 22. So that's the value you want to put on the X. So this is a little bit different. You got to be careful that you're going to put in the 22. Now to do that, right, we go to second calc. There's the value there. And we're going to put in 22. And it's going to give us a value of, there it is, 67.9137. Yeah, 67.91 cents per liter. So we can use it to estimate the value. Okay, now let's look at the next question here. Determine the average price of gasoline when the average price of gasoline was 56 cents. So again, you can't put in the X value, so we got to go back and draw a horizontal line at 56. To do that, remember, go to y equals. There's the equation, so let's go down to y2 here. We're going to plug in a 56, and that's going to draw a horizontal line across the graph here. There it is there, right? Really can't see it, but you don't need to change the windows. It should handle it when you want to do the intersection point. Okay, so let's find the intersection point. Second calc, intersection point, enter. It's going to find the first curve, second curve. It's always going to give you your guess, and then it should give us a value right there. 16.46, 16.47, sorry. So what does that mean? 16, year 16? No. You got to remember, we start at 1979, so you got to add that 1647, so the year was 1995.47. I mean, we don't usually do that. So the year was 1995. Okay? So once you get the data in there, you can do the regression, work backwards, get the equation, plug in the equation, and then you can use it to answer a whole bunch of questions. Okay.